All right, welcome to section 12.1 on composite and inverse functions. So our objectives are to introducing composition of functions, recognizing one-to-one functions, finding inverse functions, and finally using tables and graphs to express inverse functions. So composition of functions. If f and g are functions, then the composite function g, and then this is read of g of f, or the composition of g and f is defined by g of f of x is equal to g of f of x. And again, this is read g of f of x. So what we're doing is we're plugging f of x in place of x in the g function. Okay, so that's how it's working. So the compositions of g of f and f of g represent evaluating functions f and g in two different ways. When evaluating g of f, function f is performed first, followed by the function g, whereas f of g functions, g is performed first, followed by the function f. So basically what we're doing is we're plugging in this one into that, or this one into that. Okay, so if this one has stuff we have to do, then we have to do it first, and then we plug that into G. And if this one has something to do, we do it first, then we plug that one into F. So depending on which one is first, we do that. So evaluate G of F of 3. All right, so f of x is equal to x squared, g of x is equal to 2x minus 3. So if we're doing g of f, what we need to do is plug in 3 into x squared first. Okay, and so we're going to do an f of 3 first. So it gives us 9. And if we plug 9 in now into the x for g, we have 2 times 9 minus 3, and that gives us our 15. Okay, so that's going to be how this works. You have to read which way it goes, plug this into the first closest function, get that answer, take that answer, plug it into the first function. So what about this one? Same thing. So we're plugging in 3 into here, so that's going to give us 6. And then we're going to plug in 6 into the g, so then we have 6 squared minus 2 times 6 plus 1, and that gives us 25. Okay, so that's how, when we do g of f of some number, that's how we can work on those problems. Now use the tables to evaluate the expression f of g of 3. All right, so we're going to do g of 3 first. All right, so g of 3 is going to be, well, here's 3, g of 3 is 2. Now we're going to plug in 2 for x, and so we should get out 5 for f of x. So we do that. We can look here, g of 3, that's 2, plug in that, and we get 5. So basically, again, we plugged in the 3 for x here, and we did it for G, got 2, took that 2, went all the way over here, plugged it in here, and we got out the 5. All right, here we're supposed to use the graph below to evaluate G of f of 2. All right, so same thing first. We want to do f of 2. Okay, so where is f and where is 2? All right, so f of 2 is, well, here's our function f of x. 2 is here, that's going to be a 4. And so then if we plug in 4 into the g of x, well, g of x is here. If we plug in 4 here, we should get out 2. And so that's how it works. So really, we don't even have to redraw the graphs or anything. We can just say, okay, plug in 2 for f. So f is here. So we go x is 2, go up here, have that. So that's going to be 4. That's going to be what we plug into g. So for the x. And so if that's x, then we go up here and we get 2 as our final answer, which is what we see down here in this corner over here. All right, let's stop there and we'll come back for some more.